Hey everyone, thanks for having me back. As you all know who I am, I'm an open source software developer. I have spent a lot of time in digital preservation thinking about how to democratize the process of like working with different tools. I know a lot of people want to be programmers, but it's not necessarily that everyone has to be a programmer. Also, I should just say there's a full paper around this, so if anything feels a little less fleshed out in this presentation, you can have a look at the full paper. It was written for iPres, but they didn't accept it this year, so I really appreciate having a forum that I can actually share some of this. So how interactive is everyone feeling? Not everyone can be a programmer, or let's see if this works. I don't usually use transitions. Here we go. Who here considers themselves a programmer? Can we have hands up and keep them up? All right, thank you. Until the end of the slide. Thank you. Who's contributed a policy to MediaConch? Okay, one more. Who has contributed a signature to You got to keep your hands up, people. Who has contributed a signature? There's a hand here missing. Thank you. Who has contributed a signature to Pronom? Okay, well, one more. All right. Who has written a regular expression? Oh, a few more. Who has written HTML? Oh, a lot more. And who has contributed something to FFmpeg provisor? All right. So not everyone can be a programmer, but I think there's a lot more of you who are programmers in here than maybe previously thought they were. You can put your hands down now, people. Thank you. So declarative programming is a high-level program that describes what a program should do. In the most basic example, it describes the what and not the how. In the most basic example I could think of, I say, good morning to Dave at dawn. And maybe this is like something you've programmed into an Alexa or something, and at dawn, someone called Dave is going to be greeted, good morning. If you're going to do this in imperative programming, which talks about the how, which is kind of like the more traditional view of programming, where you have to like figure out exactly how something is going to happen, you might write something like this. At 6 o'clock in the morning, while true, and this is just a loop that'll keep on going, if time.now equals dawn, which is 6 o'clock in the morning, print good morning, Dave. But there's at least two things wrong with this. It assumes I'm in the same time zone as Dave, and it doesn't have any awareness of the seasons. So 6 o'clock is not always going to be dawn. So a really simple piece of code, but by the time you start thinking about how this is actually going to work, you're going to start adding a lot of new functions. 10% of software is writing code and 91% is debugging. If you go down the street there, you'll see the sign over there. And yeah, the idea, we got side effects on this slide. So yeah, this is not printed as nice as it should have. But yeah, so imperative programming basically has two layers, which are difficult to see here. But between layer one and the computer, so the how that you've written and the computer are side effects. So it's all the bugs that you're going to have to figure out. If you have a declarative layer on there, you have something called network effects. So there's potentially lots of people writing in a declarative style on top of a layer 2 imperative that, yes, someone has to program. But if that layer 2 is, very solid, the declarative approach on the top becomes even more solid. And the outputs of that can be shared to many more people. And we have, and so the benefit flow, you get some benefits from someone maintaining the layer 2, but you have a lot more benefits for people who maintain the layer 3. And these mysterious emojis were meant to be people. And I was going to make a joke that the benefits flow up to the members of Queen in Bohemian Rhapsody, but I can't make that joke right now. We have examples. So we have examples that we know very well in the field of digital preservation. Schematron is one I really wanted to remind like the digital preservation community about. Like, it's from 2012. I don't necessarily hear a lot about it anymore. It is very much an XML-based approach, but it looks for patterns within an XML document that people can make assertions about. So, and Johan van der Neef, who developed JPlyzer, used Schematron to like say, okay, well, I've got this capability to extract all the information I have about a JPEG 2000. How do I then create a validation tool for it? So I use the output from JPlyzer, put Schematron over the top of it, and say, you know, reason about it. So a really basic Schematron example is test when JPlyzer says, is it a valid JPEG 2, and it appears in the report, it either passes or fails this test. And of course, I can't not mention MediaConch. I think it's about 2015, but it's very specific to digital preservation workflow, more specific to digital preservation workflows, and accommodates more tools. But it's the same. This is another example of declarative programming where you declare the what you want. So you want a TIFF that is that's got zero compression. And if it has these two things, it passes, and if it doesn't, it will fail. And so it might fail one of your workflows. In plain language, that looks like that. I just wanted to, another example we have is pronom. I think what's really interesting about, so if you don't know pronom is a format identification tool. It contains these regular expressions, and these this is another form of declarative programming. In this instance here, you ask, does the start of the file have the byte sequence bad food 1? Then look 23 bytes later, does it have the sequence ACDC 1, 2, 3, 4? And then at some point in this file stream, I'm going to find cafe food. So look for that. And 72 institutions have contributed to pronom in 2023, this was. And so that's 72 had contributed, and like everyone across the globe benefits from that. Because like as soon as it gets into the pronom database, it gets to everyone. I really like this example. This is from Richard Lehane. I don't think he like continues to maintain it or like had any plans to maintain it. But what I like is it's a specification that describes rules about a digital repository. We see the same pattern in premise and premise rights. But yeah, so it describes access rules for file. And if you write, so that's the declarative bit, and people can write different tooling underneath that support this standard, and you'll have a consistent behavior across every implementation. And we see that a lot in standards and protocol development. What I like is it really felt like an Nginx for archives. So sometimes that that layer between your computer and the outside world that's running a web server is often just a text file that describes some rules that says someone can see this, but they can't see this. It's like a very powerful mechanism, but it's kind of scary when you think about how it is just a text file. So the importance of declarative that I wanted to bring to the group was about where work is done and how it's done most simply and efficiently to achieve what you need to achieve. It can be very easy to start designing software. And as a developer, and if you have a developer or access to a developer, or you are a developer, you can really just start writing. And before you know it, you've got 100 functions doing a lot of stuff. But I think it's really important. I think one of the messages of this is to think about different abstractions, different ways of planning your work, where there is another way of doing it that doesn't involve that can maybe allow other people to access what you're doing, like perhaps building a declarative layer on top of what you're doing. And yet, you scientists were so preoccupied with whatever they could, they didn't stop to think if they should. And you see this a lot in software development. A piece of software does A, and someone, probably a higher up manager, says, Can I do B and C? And it's like, well, it doesn't really need to. Like, well, let's plan this and like figure out the right place, the right abstraction, and everything else. And yeah, and so that's Maslow's hammer. Yeah, what I wanted to do is like point out that other tools exist similar to media info and you know, and media concepts on top of media info. FQ is a tool for it's JQ for binary formats. I'm sure it's probably already been presented here in the past, and it's definitely one to look up. You know, can we take the output of something like FQ and build a community around it in a sort of declarative way, like maybe something very media conch looking that takes the outputs of FQ and then like allows us to integrate sort of a declarative layer of using it into our digital repositories, like for validation and more identification. So yeah, and you know, that if we're thinking about the next binary format that we're going to interrogate with an imperative language, maybe we look at FQ first and figure out, you know, what abstraction we can build on top of it. So I think if you are able to architect a declarative language for something that a lot of people do, it can lower barriers. It can make it easier to access network effect and provide opportunities for more people to engage. Like Pronom is just such a good example. Yeah, and I don't use MediaConch right now, but I assume there's a strong community of people contributing recipes to that. Theoretically, there are fewer lone coders, and it does make it easier to collaborate. And the more people engaging in a project or something like this, you can start to explore what the bigger implications of this are. So I was interested in, I wrote a paper about converting premise events to an actual event-driven based system. And when you look at the projections that you can build on top of event-based systems, they start to look a little bit declarative in what they're doing. And so you can maybe start reason about much more longer running processes and their outputs. And that could be quite a cool thing to think about. But yeah, I think you always need to think about design patterns. And I think one of the things that really caught me off guard was when I started to think about this, like I had all the different links, I was like, but I didn't know what it was I was looking at. I didn't actually, from my experience in the industry, I didn't know this was declarative programming. So what I wanted to share with folks was like, maybe if you don't know it's declarative programming, maybe that's helpful for you too. And so if you can name it, you can tame it. And there are other paradigms out there that we, you know, instead of like starting to just like, let me just write a Python script for this, maybe there are other ways of doing, you know, writing the code, other paradigms we can consider. Functional is another paradigm where it theoretically has no side effects, but it's a difficult paradigm to understand. But maybe, you know, with some of the integrity and the sort of precision we need in what we're doing in archives and digital preservation, maybe something like functional programming is a way of approaching like some of the sort of back end stuff that we're doing, where we generate fewer bugs and we get more consistent outputs. Requirements and use cases are always important. I think, yeah, it's another thing I wanted to come back to is just the idea of like just resurfacing some of this, like especially the schematron stuff, looking at prior art and what exists and whether they can be harnessed for something else. And also the idea of building interfaces and standards like the meta package that Richard started working on. And so if you want to go fast, go alone. If you want to go far, go together. And if you want to go further, document your use cases, design a standard, validate it with a team of your peers, and then go together, which I think is something this community knows especially well. And I know it's hard work to maybe sit down and think like really long-term and strategically about a piece of software and where you're going to take it, instead of just like, again, it's really satisfying to like just start writing code, but maybe you know, we do start with standards and then we look like, oh, this standard might benefit from like a domain specific language or like writing a declarative layer on top of it. And I think that could be really satisfying for people too. And it might seem a stretch. I hope it doesn't. But it's the network effect of this stuff, like the way that people contributed to the proton database or MediaConch, and potentially could have done more with the schematron stuff as well. Like the network effect is massively important, and I think it is one of those design decisions that you put into your architecture. It's like, can I build this in a way that other people can use? And if other people are going to use it, what does that need to look like? And again, I know it's difficult. I know we don't have like all of the resources. We have to really think about ourselves a lot of the time. But, you know, open source is a thing, and network effect is kind of rigged to like benefit from network effect. And that's kind of the sort of the one takeaway I wanted people to take from this is like, I think everyone who engages with an open source project, whether writing documentation, logging issues, they're all programmers at heart anyway. And like they don't have to like write a line of Python to really bolster a project. Take the last presentation as an example of that. And I only just saw this, the Wikipedia motto of just be bold. Like if you have you know, and I know there are people in the room that like will jump into a GitHub and just like log issues. Just do it. Don't be scared. People will always be responsive to people who are engaging with your projects. This talk was inspired by a project that Bernhard and I tried to get off the ground. It was like, how can we get a group of people together to like share and like build a piece of software from scratch, satisfying a new demand? How do we make a didactic opportunity for people to get like experience building software, coming up with requirements, answering the questions about, you know, how do we resolve, like, how do we have this feature and not this feature and so on. It didn't get off the ground, but after we took some time to think about alternatives and sort of and then we we didn't chat for a while, but like the seed of it helped me think about like this as a presentation that I thought might be useful for people. And if people are interested, there's a link to the paper and other resources. And I'm happy to take questions if there's still time. Thank you.
Thank you. Sounds awesome. I get it, and I totally don't get it. In terms of like, I would not know, maybe it's so obvious, like, so I would declare something, and then how would that happen to become code that actually runs? I'm like missing that part.
I'm sorry, can you rephrase the question?
So I would declare something, like I'm thinking schematron now as an example. I probably would not do that by hand, because if I could do that, then I would consider myself more of a coder. How do you jump from that to actual running code?
Yeah.
So you're like, and then you declare stuff, and then code's happening, but I was missing how.
Right. It is kind of, it's what's it called? It's the problems at both ends anyway. Like you either have to design so that you build the declarative layer on top, so that people are able to engage with it in that way. So like the example of Meta was, you had the standard first and you could build the implementations on top. But the people who would use that standard would be doing the declaring, and people would be building the implementations that took away the work of programming. And then the other way around is, do tools exist that already have outputs that could be harnessed? Like JPLizer existed. So now you can write a layer on top of JPLizer that does interpretation in a potentially very lightweight and easy way that other people can engage with. So you either need to write the standards and think about building the declarative layer, or have some data you can use that you can then use declarative methods on top of. Right, I hope that helps a little more. Thank you.
Any more?
Hi, Ross. So have you thought about implementing this with things like Demystify or some of the other applications that you maintain and have created, and how you could incorporate that?
Have I thought about eating my own dog food? Is a phrase from, I guess, the UK. Yes, but only recently. I think in my day job as well, we have there's some things that I'm thinking like might be better off if the abstraction was like higher, so that more people could engage with it. Have I implemented it yet? No, and I do think it would be a challenge. I think, you're like doing second order thinking as a developer to like write the imperative stuff and like a way of people engaging with it. But there's an interesting language called Python Behave, which does feature testing and behavioral-driven development. But if you look at that language, that actually does like satisfies some like really nice properties of the declarative language that you might be able to put on something like your other Python code and like get this kind of output. Anyway, might be interesting.
Any more lingering questions in the room?
Thank you once again, everyone. I appreciate it.
Thank you, Ross.